switch screens and make you presenter. Everyone, enjoy your awesome webinar.
All right. Good morning, everyone. My name is Jason Straight. We're here for the next session in our data lifecycle optimization series, architecture and availability. So we're going to be covering two of the pillars of our approach that Pragmatic Works has in today's session. For those of you that don't know me, my name is Jason Straight. I'm Solutions Architect here with Pragmatic Works. Been working with SQL Server for 17-something years, long enough that I really just don't bother to count anymore. And I've probably been saying it's been 17 years for a couple of years now. Been around, played around with SQL Server in all sorts of different capacities, everywhere from a data warehouse developer when I first started out, even though I didn't know what a data warehouse was, to a DBA, and now back to doing architecture work on both data warehouses and transactional systems. So what we're talking about today is architecture and availability. And it's really that idea that you have to have a sound foundation for your platform to get what you need out of it. If you don't take the time, it doesn't matter what you put into it, you're just not going to get the results that you're expecting. And that's kind of what we're talking about. And a lot of times when I'm talking with organizations and we're talking about where they are within the life cycle of their data platform, they start talking about how they've organically grown. And organically grown over time into what sometimes becomes kind of a mess. And the idea that we want to get to, and the things that we're going to talk about today, is how do you go from growing organically and having kind of a mess of the architecture to smoothing that out so that you can really get through and have the platform that you want and the platform that you need. And the way that we do our approach, and this is what we talked a lot about on Monday, and I'm just going to do a brief intro here so that you guys know what we're talking about, is the idea of data lifecycle optimization. It's the process that we use here at Pragmatic Works to look at platforms. And it's basically the idea of starting off with architecture and configuration, which is half of what we're going to be talking about today, and then moving into availability and continuity. There's a number of other phases to the process, but we're going to be just focusing today on these first two. And with these first two, we want to be able to take a look and see, where is it that we're going to go when we're building out our environment, and what are the things that you need to be thinking about. Now, when you're talking about architecture and configuration, there is the need to make sure that this isn't just for DBAs. There's a lot of times where I'll get into architecture discussions and availability discussions especially, and the main focus becomes just the transactional platform. It's not just for the data, the DBAs and the transactional platform. It needs to also be for the entire data platform. We need to stop thinking about data as transactional or data warehousing and think of it as an asset that the company has in various forms. The data that comes out of your transactional system may not be what's driving the immediate business, but it's probably going to be what's going to be driving the future business. So what we need to start thinking about it is everything from a data platform professional. And so if you are working with data, you do need to have a solid foundation for your architecture and the ability to always get back into the data that you have and have that availability on the platform. And so the two things that we're talking about here today are going to be architecture and configuration. So we'll start off with architecture and then we'll get into the availability and continuity. If you have questions throughout, please put them into the Q&A. When we get to the end, I'll go through all the questions that we have time for. I'm hoping to leave a bit of time at the end for questions because I'm expecting as we talk through this that it'll generate some thoughts that you guys want to share or have questions answered. Anything that I don't get to, I'll cover with a blog post following this presentation so you can get those answers. When it comes to architecture and configuration, though, there is kind of just some first things that you need to think about when you're looking at that. When you're building it out and you want to have that platform, you really need to understand what those needs of the platform are. What is it that you're planning to do? And you want to make sure that you're planning ahead, because the time that it takes to go back and re-engineer always takes longer than if you would have just planned for it ahead of time. Always make sure that you're involving those data consumers in the design, and then build out a logical architecture and get that architecture validated. One of the things that I see quite often is, you'll get a great design and it'll look great and you'll work through it and you've spent all the time, and I've done this myself, where I get the whole thing put together and then I get someone else to take a look at it, and I've been laughed at. Actually, I used to have a DBA that I worked with back when I first started out as a data warehouse housing professional, that every single time I brought him a design or a recommendation for architecture, he would just say no. Now, he said no with a purpose, the idea that he wanted me to validate my decisions, validate and go through, because before we implement that physical design, which is the last step of architecture, is to make sure that it was exactly what I was looking for. You need to be very intentional with your architecture and not be reactive, because when you are reactive, you end up having to make a lot of what's the word here? You're going to have to make a lot of trade-offs, and trade-offs that you wouldn't typically have made if you were planning from ahead of time. And the interesting thing about what's been happening in the last few years, and what makes this idea of being intentional even more attractive, is that what we can do with our platforms and what we can build out has really changed. In the last couple of years, cloud technologies have become mainstream. Now, they may not be something that you're currently using in your environment. There's a lot of companies that are still acclimating to the idea of doing any sort of offsite or cloud-based deployments, but if you start to look at what's happened because of that, our environments have really turned into this Lego land of capabilities, where you can just pick and choose the different capacities and components to build out your platform. And this applies to both on-premise, appliances, and then the cloud, because of what's been changing with all of those pieces. And so when you're looking at the architecture, there's basically three main areas where you get to look and how you're going to build these out. So the way to think about it is, yeah, there's all these Legos, and there's different kinds for different pieces in different areas, and they're not mutually exclusive. When people talk about cloud, it's not about it's only or just the cloud. It's never only or just an appliance, and it's not. It may now be only on box or within your own data center, but that's probably not where you're going to be in the future. And if you start to take a look at what you currently do with your platform, you may find out that some of these technologies that we want to do, maybe you're already kind of doing them. Maybe you're kind of already leveraging them. There's quite a few times where I talk to people about cloud-based architectures and talk about that off-site storage and that off-site data center. And there's a lot of people that have a little bit of resistance to that, but if you think about what cloud is basically just hosting. And I've talked to customers where they're like, well, we can't do cloud because it's not going to fit for our organization. And so you ask, the follow-up question is, so where's your data center now? And the answer is sometimes, well, we use this third party to host our data center. Well, in all reality, that's almost a cloud. It's a cloud with less features probably, and with probably a different level of customer service. The other thing I've talked to people about is when they're doing off-site tape storage. Now, off-site tape storage may not be cloud-based, but sometimes it is, or it might be online and their ability to push that out there, but that's also similar to a cloud. So when we're looking at this, though, regardless of whether you're going to do box, appliance, or cloud, the story is kind of the same. You want to start looking at how much data you're going to have, What is going to be your throughput? Where is your data center? What is your expertise in hosting machines? Quite often when we start looking at what it is that you do as a business, it may not be that your primary business is to have a data center. A lot of small to medium-sized companies will they'll have that one technologist that's the man of or woman of many hats that handles, maybe they're a director of technology, but they're also the sysadmin, the network admin, and all of those pieces. And that's not really what your main focus may be. Maybe your main focus is really on delivering the data, but you have to wear these other hats because you don't have any other options. And so look at when you're doing your expertise, when you're doing your architecture and configuration, is what is your expertise with having a data center? Is that your main business? Is that something that you can focus on? Or do you need to maybe leverage other resources? And also when you're doing any architecture, what is your platform expertise? One of the things that's been kind of interesting is you talk to, or you look at a technology like replication. Replication is a fairly, overall it's kind of a simple technology. Take transactions as they come through, put them into a queue, send them out to all of the consumers, and then replay them. Sounds simple enough, but if you've implemented replication, transactional, or snapshot, or any of those, you probably realize that it's not really that simple. And so when you're leveraging and you're bringing in pieces for your architecture, you have to make sure that you have that expertise to be able to support those. I worked with a customer at one point that decided that they were going to put everything into message queues and into XML documents, and it was going to be a database that had one table that was basically every element and node in attribute from every document shredded out into one giant table. So when they got through one iteration of leveraging this, and their intent was that they were going to use this platform for all of their customers that were coming through. So they got one customer through, and that customer generated 1 billion records. And suddenly it just didn't work anymore. It didn't come together. And the one thing that they forgot when they were building this out is that they were using cool technology, but nobody knew how to work with it, work with XML or handle really large tables. And so it didn't align with their expertise. And as you're building out architectures, make sure you're leveraging everything that you have, using the right expertise on both your platform and the technologies that you're bringing in. Now, when it comes to looking at your platforms and you're building out your architecture, when you're choosing the components that you're going to be bringing in, the first thing that you're going to probably go to, and this is the default that many organizations go to, is, it's a tried and true pattern of using a box solution. So this is installing SQL Server on-premise. And I'm not going to spend too much time talking about this area because this is something that we all know. We all know about commodity servers, high-end servers, where you have the ability to basically build out an architecture that you want. The thing that's kind of interesting here, though, is that we've really kind of changed the way in which we look at doing our installs. It used to be that there was a much higher majority of machines that were physical implementations. Install it on that machine, build it out, and go forward with that from there. But in the last few years, there's been a very large shift to going to virtualized machines. And that's a good thing. And the reason why that's a good thing is when you look at the pricing for things like SQL Server Enterprise Edition licensing. It's not the cheapest licensing cost in the world. There's lots of people that go out and talk about how it's a bit spendy right now. But when you start to look at what it is that you're using it for, you can look at virtualization and the ability to overcommit CPU and overcommit memory to looking at what your workload is. A really good example of where you can overcommit your resources is when you're looking at something like SQL Server Integration Services and SQL Server Analysis Services and Reporting Services. Those features oftentimes don't run at their peak at the same times. So integration services oftentimes will push into analysis services, But when it's pushing into analysis services or it's reprocessing the cube, it's probably not also processing data in its data flows. Reporting services probably isn't running at peak when your analysis services cubes are processing all their data. So with virtualization, when you're architecting out your solutions, you can start to look at those and maybe have a virtual server that, sure, you've split apart integration services, reporting services, and analysis services into different machines, but maybe it's on a machine that's licensed at the OS level or the host level versus being licensed at the individual virtual machine level. And that way you're able to make the best use of those resources. And so those are the things that you're going to want to look at, because it is okay sometimes to overcommit on CPU when you're building out. Now, along with that, when you're building out, there are some times where you don't want to spend a lot of time on the architecture and the design. So when you're looking at virtual machines and building out your virtual platforms, oftentimes it's a clustered virtual machine with a number of nodes that you have all the CPU that you need. The problem with that sometimes is that you need to do additional engineering and effort in order to get the platform to work how you want. And that oftentimes happens when you're working with things like data warehouses. Now, data warehouses aren't necessarily rocket science, but there are difficulties in making sure that you're properly aligning CPU and getting the right parallelization out of the platform. One of the things that does well when you're looking at building out architectures with data warehouses is you want to get as much parallelization of the platform as possible. And actually, if you can force parallelization across all of your queries, you can oftentimes get a far superior reporting performance and data loading performance than you would with just a typical symmetrical processing implementation. And when I say symmetrical processing implementation, or SMP, what I'm really talking about is the typical way in which we install SQL Server, where it can be a parallelized query, sometimes, maybe not always, and maybe it'll use 10, or maybe it'll use 2, or maybe it'll use 12 CPUs each time, each discrete time that it runs one of those queries. That works great for transactional processing, where you need to get all those transactions through as quickly as possible. But when you're doing things like data warehousing queries where the transactions are coming through a bit slower and you just want to be able to push the resources at it, a system like Microsoft's analytics platform system with parallel data warehouse can give you that capability to make sure that every time a query runs, it's going to leverage all of the CPUs that it has available. Appliance, this is one of the things where you can kind of take this appliance solution piece and drop it into your architecture, and so that you're not going to spend all of your time configuring and building and tuning and engineering your SQL statements and the platform itself, but instead bring in a platform that's already been pre-designed, pre-configured, it's ready to go out of the box, and you can have it, it's already engineered for performance. The additional advantage to using an appliance is you may not have expertise all the time in all the pieces that you need to bring in. Sometimes you just want a cookie cutter data warehouse platform that you can just bring in. The appliance offers that. It also offers the ability to build in or build up a cookie cutter Hadoop implementation. So with HD Insight on Microsoft's analytic platform system, you don't have to know about, how do I build up the nodes, how do I set up the architecture, how do I pull all these things together. I myself am fairly new. I've only been working, fairly new to Hadoop. I've only been working with Hadoop now for about a year, and so I don't have a lot of experience building out Hadoop clusters. With appliances and for building out that architecture, think back to that. Do you have the expertise with the platform? Sure, I could find a bunch of machines and I could build up a Linux environment and I could install Cloudera or Hortonworks and get it to work, and I could invest that time, but maybe I don't have that time to invest. And that's where you can look at things like the Microsoft Analytics Platform System with its HD Insight nodes to be able to help your architecture in that way, so that you don't have to build up that architecture. You can just rely on an external vendor, in this case Microsoft, to build that out for you. The other option, or the other set of components that you can bring in, is cloud in the case of a lot of what we work with customers is Azure. And it's not an all or nothing type of choice. It's really the ability to augment what you're doing with additional features and capabilities. And so what cloud is if you're not familiar already, cloud is basically data center hosting with a lot more service around it and generally a lot more options. So you can have virtual machines, just like you can with a third-party data center. But there's also things like platform as a service, where you can have an entire database that's, for the most part, completely managed by a third party, in this case Microsoft. And it's just the idea of having tables, having an instance that you can connect to, the store procedures, and all those components that you want available without having to go through and do configuration. And when it comes to the performance that you need to get out of the platform, there's basically a dial that can go up and down to determine how much you need. Now, it's not perfect for every single workload, but it is something you can think of as a piece to augment what you are doing. You can extend, using things like virtual networking, your existing physical on-premise data center up to the cloud. And that makes kind of a big difference there, because the way in which the cloud is there and available is it's a service, it's an offering. It's something where if you need a new server today, you can actually ask for it. Because that's one of the reasons to consider the cloud. So it's one of those driving features, is that as you need additional resources, you can just get it. It's a very elastic experience of what, by and large, what we would see is an unlimited pool of resources. Now, there is, of course, some sort of limit that's out there, but I haven't seen it yet, and I'm not sure that it's one of those things that should be a negative for the platform, because they're continually building up the data centers to have more capacity and more throughput. Now, the other thing to be looking at is there's more to the elasticity beyond just being able to add on additional components. You also have the ability to expand what you're really doing and pulling together, and how you're going to pay for it. One of the big things that you look at when you're building up platforms is sometimes people don't get test and dev environments because they don't have the capability to have additional machines around. Well, that elasticity of the cloud, when you're looking at your architecture, gives you that ability, because you can start to build that out because you have the ability to pay for what you use. The cloud in all of its different incarnations, whether it's Azure or AWS or any of the others that are out there, it's all about paying for your consumption, whether the consumption is storage or compute. And generally, that level of payment is down at the minute. And so you can use things as you need them. Do your development work and then shut it off for the weekend. But being able to have exactly what you need. Now, when you're looking at this, there's a lot that you can build out, and there's a lot that you need to consider when you're looking at your architecture. And there's a lot of reasons why you might be looking at your architecture again. That need to build out and enhance your transactional platform, or build out a data warehouse or a data mart. Maybe you've already got a data warehouse that's already set up on premise, and you just need a slice of that put together and available for another group. And you need it to be separated and secure and put together in a way that nobody else can get to it besides the people that you give access to that instance. You can augment your platform by expanding out into the cloud and developing a hybrid approach to your platform. You can also look at bringing in some scale-out capabilities. One of the things that we often do with SQL Server when we want to increase the capabilities is we scale up. Get a bigger box, more CPU, more memory, more storage. But that's not always the solution. You don't always, if you go from 6 CPU to 12 CPU cores, get twice the performance. Sometimes what you really need to do is, instead of having 12 CPUs, maybe have 2 machines with 6 CPU each. And there are some options that we have out there where we can start to leverage those kind of scale-outs. And that's kind of what I want to talk about here to wrap up this piece on architecture and configuration. Because as you're building out your architectures, there's things that you want to start thinking about that have changed, and it's the reason why I talk about cloud, and it's the reason why I talk about how we have these Lego blocks now. Because we can start to do things a little bit different. Microsoft's announced in preview right now that they have this ElasticDB with SQL Database. Now this is currently a cloud option, where what you can do is with a head node to your, and an API through your application, you can aggregate together some results from numerous SQL Server database shards, or you can access directly those shards to distribute out your data. And the idea here is that as you get more data, that maybe you don't get the performance that you're looking at out of having one copy of the database. Maybe the next step for getting better performance is to split it into two databases, but still being able to access all of that data across. And so that gives you the ability that as you need to expand your capabilities, you can then add on and build out. And as you need to contract, because maybe things are getting slower in your organization, you can also then contract as well. So that's one way that you can look at bringing in scale-out technologies. The other thing that you might want to think about when you're talking about how do you design and build out is if you've got analysis services, one of the things that sometimes happens is you get a cube that gets to a size where reprocessing becomes a significant challenge every day. And so maybe on the back end you've got a data warehouse, and between you and the master SSAS server, maybe instead of just having your SSAS server with your database and having it all partitioned, you instead have between there separate analysis services instances that service specific shards of your data or specific partitions of your data. And then as your users are coming in and getting into your platform, they're also not going to a single analysis services instance. They're actually going to a number of query servers where you've got a load balancer that's determining which one they go to, so that as you have more queries coming in or as you have more data building out into your platform, you're able to easily expand out and build out your platform and not have to scale up with your servers, but you can stay with middle tier or middle of the road servers that are generally a little bit less expensive and get more linear performance improvement. And you can do the same thing with other features like SSIS. Have multiple SSIS servers in there so that once you get to a point where maybe the CPU is bottlenecked on one SSIS instance, bring in another SSIS instance to run the other jobs. It's not always true that as you add in more CPU to an SSIS package that it's going to allow you to run other packages, because SSIS packages can sometimes be memory hogs. Actually, I know that they can be memory hogs. I've dealt with that quite a bit. And so you have these capabilities. Now, generally, you could do these all on premise. You can. These will work on premise. The ElasticDB isn't technically supported on premise, but I'm pretty sure since it's just an API that calls into your SSIS instances, your SQL Server databases, you could do that on premise as well. But when you're looking at this from a how do I make sure that I can build this architecture and have it just work, and then scale it up and scale it back, go up and down as I need, cloud delivery of these types of solutions really give you that elasticity. Because while sure you can scale up, as your platform and as your entire organization scales up or scales out and builds more and more capability along there, if you're doing these via physical machines, well, once you've added a physical machine, you've made the expense, you pay for it forever. So maybe you have it all virtualized so that you can scale back down. But the reality is a virtual environment that you're going to build out is going to always be able to satisfy the needs that your organization has at peak. And if you don't have elasticity where it's going up and down between multiple departments, you're not really gaining anything by having something that can scale down. So you could do these all on-premise. The trouble is that, once you make the investment, it's a final complete investment. So the next area to talk about is availability and continuity. Now, the interesting thing about availability and continuity is everybody thinks it's not going to happen to them. You're not going to have an outage. It's just not going to happen. Now, with transactional systems, and I was really glad about the survey at the beginning, 60% of you guys have within the last 6 months or less tested your availability and continuity. That's great. That's excellent because that means that people are getting it. For the rest of us, though, that haven't, my example that I like to talk about with customers is it's the example of a flat tire. I'm not going to get a flat tire, but actually I am going to get a flat tire. It's not a matter of if, it really is a matter of when. Because unless I replace that tire at a fairly regular interval, it's eventually going to go flat. And actually this year when I went out driving around on my birthday with my kids, I got a flat tire. And it was a very flat tire. I had 2 nice giant holes in the side. And when you get a flat tire, that's when you have to go to your disaster recovery plan. That's when you have to start looking at availability and continuity. What is it that you're going to do in order to survive this outage, this flat tire, this lack of data? Eventually you have to decide that, when you get the pudding and you throw it at the fan, what's going to happen? It's not a matter of if, it's a matter of when. And so when you're looking at availability, there are 2 main things that people want to look at. The first is, can you continuously access that data? That's one of the main things about continuity. Can you continually access it? If it can't go down, how do you achieve the ability to not have it go down on you? Alternatively, is when it does go down, how are you going to restore access to that data? So when you have that flat tire, do you have the spare? Do you have the ability to survive that downfall? And what is the ability to survive that? How much data loss can you have? Or in the terms of a tire, how small is that donut going to be? I know that when my tire recently went down, or went flat, I found out that my tire only supports going 50 miles an hour. When it's a 70 mile an hour zone getting back up to my house, and the place where I have my flat is 40 minutes away at 70, that's definitely an impact to the performance of me getting home, or in the terms of data platform, that's the ability to process transactions and to get the value back out of your system. And so when you're looking at availability and downtime, there's 2 key things to look at. So the first 2 things that we looked at was what is it that you need to have available. The next 2 though is how do you justify your solution? What is it that makes it so that you can accommodate for your planned and unplanned downtime? And what is it going to cost for the solution? These 2 pieces are going to tell you exactly what availability solution and continuity solution that you need. If your platform going down for half a day is only going to result in maybe a $5,000 cost, and you can figure these out by looking at what it is that people do with it and what's the cost of the platform being down. If it's down and you've got a room of users that can't access the system, and this is maybe 30 or 60 people that need to be doing some transaction processing against the platform, maybe grading tests or validating orders, if they can't be working, then that's the cost. If you can't take in transactions, then that's the cost. Whatever it is that you would typically get there, if you don't get those orders when people are ready to go to the internet and purchase them from you, those are likely sales that you're not going to get. You're just probably not going to they're not going to come back, most likely. Now, when it comes to data warehouse platforms, you have to look at the decisions that people are going to make because they have that data. If you've got a platform that is helping sales reps by doing data analysis and returning reports, there's a really cost of business there because you could lose customers by not having that data warehousing information readily available. If you've got a platform where you're providing reporting on how your customers are responding, and some of that information that collects is for talks about how there's delays and interruptions in somebody's travel schedule, not having that reporting available can affect the ability of the platform to provide value. And so figure out what that value is. What is it that people use the platform for, and what happens if it's not there? And then look at what it costs to build out the platform and figure out what your ROI is between those two. The third thing that you have to think about, and this doesn't really fit into the planned and the unplanned downtime, but it's the cost of that person that really cares about the system. There is a person that cares a lot about the system. That is why the system was built. That is why it's being put together. This is less of a factor when it comes to transactional systems because it's typically very obvious why you have it there. But when you're looking at your data warehousing and your reporting platforms, look also not at just the planned and unplanned downtime, but also look at the interruption in the systems that are affected. Because there is going to be somebody that pushed for that system that's going to want to have to make a decision. And don't wobble on that decision. Lay out what it is that you can do with the system so that they have a choice. This is what it costs. This is what you get. Because there's a few things that you want to look at when you're building this out. You want to talk to them about what the recovery point is. How far back into the past can they lose data? Oftentimes people will say we can't lose any data. Well, then that points you to a few technologies. You're obviously not going to use log shipping if you can't lose any data. You're going to look at things like AlwaysOn availability groups. You're also going to want to look at the recovery time. So how long does it take from the point in which a failure occurs until you can get everything back up? This is actually one that I see most often skipped. So someone will do something along the lines of, okay, I'm going to do full backups every day, and the database backup is, say, 20 or 30 terabytes, and I'm going to take transaction log backups I want to make sure that I don't miss anything, so I'm going to take a transaction log backup every 5 minutes. And so through the course of a day, 60 minutes, so you're going to get 20 per, not 20, you're going to get 12 per hour. And over the course of the day, say it breaks down, say at about 10 p.m. Or 8 p.m. We'll go with 8 p.m. because that's going to be 20 hours past the time that you did your last full backups. So you're looking at 240 transaction logs to restore. And so you have that database, you get it restored. And I'm pretty sure if you say that your recovery time objective is less than an hour, you got to think about how long does it take for me to wake up in the middle of the night, how long does it take for me then to restore and get the backup and pull it back down, what does it take to restore the full database backup, and then those 240 transaction logs. Not necessarily something that I would expect anyone can get done in an hour unless they're already prepared for it. So how are you going to go through and implement that recovery? And the real way to do that is that recovery fire drill. And that recovery fire drill is what I'm expecting that everyone said that they were testing at the beginning. The 60% of you, I think it was 60%, that said that you guys have been testing this. Hopefully what you've been doing is what I call recovery fire drill. Just like with firefighters, you don't want to be practicing when there's a fire. You want to be practicing between the fires so that when you have that outage, you know what to do. I worked with a company that was really intent on encrypting everything. They had all sorts of columns that were encrypted. They unfortunately did not back up the encryption key, and then one day they had an issue. Now fortunately, somebody managed to track it down, but the encryption key on their production environment something went wonky, and suddenly they couldn't decrypt any of the data. That is not something that you want to be practicing after it happens. And so you want to make sure that you're practicing this between. And when you're practicing it between, make sure it's a real practice. Don't just say, hey, next week we're going to practice doing blah, 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 so let's make sure for the next week that we really take our backups. That's not a really good fire drill. A really good fire drill is when you tell your manager, hey, sometime in the next 2 weeks, pick a time, tell me when you want me to do it, and then time me and see how long it takes. If you're not doing your fire drills under a time pressure, then you may not have be building up a successful process. You don't want to have a week or two to prepare for a fire drill. You want to just have one dropped on you. And so when you're building out that availability solution, you're going to want to look at what it is that you need. Do you need instance level, so failover clustering, or database level failover? Can you do is always on what you need so that you can have multiple replicas, or is just failover clustering what you need because you just want to have it's an all or nothing? Is it a remote or an on-site failover? So when you're doing your failover, are you covering both the eventualities of the database going down, or are you looking at the failure of the entire data center? What's going to happen when your data center goes offline? A lot of people, or a number of people, haven't thought that through all the way. There's been a few times where I've gone out to customers and said, so where's your data center? And they're like, it's right here. Where's your remote data center? Well, it's across the street. What happens if one of them goes out, the second one's going to go out. And so you got to think about those kinds of things. And then what's that effort to recover? What does it take to really implement a full recovery? And what's the complexity of that failover? If you have a failover and your RTO is 4 hours or 2 hours, how many things do you have to do manually versus scripted to get through it all? And so the one thing I want to talk about here, as we talked a little bit about some architectures in the first piece, I want to talk about a few topologies that you can put together for availability to get you thinking about how you can continue this conversation and continue by bringing in some cloud opportunity. So one of the things that you can do, and this is one that I've done with a number of customers here in the last couple of years, is leveraging failover clustering and always-on availability groups. They are not mutually exclusive technologies. So if you have a situation where you need to ensure, I need to make sure that if there's a failover, it just works. Everything comes back up, I have all my users, I have all my jobs, I don't have to get up, I can deal with it tomorrow. That's a good scenario for failover clustering because everything all moves at once, it's all tied together, it can be all within the same data center, and that just works. But what happens if that data center goes down? Now, the dream used to be, well, I would do a stretch cluster. Well, will you really do a stretch cluster? Are you really going to have all the pieces together to do that? Now, some organizations will, but most organizations don't have those 2 SANs, they don't have the bit level replication, and they don't have the expertise to put it all together. And it's kind of a pain to set up unless you've got a dedicated staff for doing the failover and the stretch cluster. But what you can do, what is fairly simple to do and not too much trouble, is you could, up in the cloud, or maybe in another remote data center, this will work with a remote data center as well, set up a virtual machine or a physical machine and set up an always-on availability group to move those databases over there to do a manual failover if you do have a full data center fault. Now, the nice thing about this, and part of the reason to think about this, is this really means that anybody and every organization has the capability to do failover clustering to a remote data center. Because the costs for Azure and the cost for cloud is generally substantially lower than going out and buying a new physical location, purchasing some servers, getting all the licensing, getting that all set up. And so you have some capabilities there to start thinking about that. The other thing to think about when it comes to availability and continuity is, what about your backups? You know, oftentimes we're putting backups to disk, and then we copy them to tape, and then the truck picks them up, and the truck drives them somewhere. And then if we need them, we call the company, and the truck puts them back on. Well, the company puts them back onto a truck, and it comes back, and then we can restore them. To get around one of the main problems, and one of the main problems with bringing in trucks, is that the truck, once it leaves with your tapes, getting it turned around is oftentimes extremely expensive. I've actually never worked with a company that was willing to pay for the expense to stop the truck and turn it back. I've had them ask. When they found out how much it costs, then they went to a different solution. They still sent them off on trucks, but then the solution was that, well, we're going to send the tapes off the truck, but we're going to keep a week's worth of backups on premise. Well, that's kind of silly. A week's worth of backups is a lot of disk space. It can generally, in a lot of cases, make you start to make compromises in how you're going to back things up. The compromise that I typically see is that we're going to back up the transactional system, and then if we have a failover in the data warehousing side, we'll just rebuild from scratch. I've done rebuild from scratch a number of times. It isn't pretty. But we make these compromises because of the assumption of the available resources. And when you think about Azure storage, or you think about cloud storage, if you've priced it out, you've probably seen how it's near or approaching zero for the cost to have cloud storage. So with cloud storage, you can put these up to folders, and in this case, I'm going to talk about Windows Azure storage. You know, put them into folders that are not publicly available, privately available, that you need a key in order to get to. And so it is a secure platform, and you can encrypt the database backups as you put them up there. And that gives you that ability that when you have a failover, you can then do your restore. You can restore it within the cloud. You can restore it to another data center. You have that ability to take it where you need to bring it, to have the platform with the availability and the continuity that you need for your platform, regardless of whether it's a transactional system, whether it's a data warehousing system. You know, if you're taking the time to build out a data warehousing platform and then choosing not to have it available or not to have a continuity plan for it, do you really actually need to build out that platform? And oftentimes it's silly when you propose that question, and because obviously you're spending the time and the money to build that all out. You do need it, and it is desired, but you have to make sure that you're treating it like a first-class citizen amongst all of your transactional systems. And with the Lego blocks that we have today, with the ability to do things in Box, Appliance, and in the cloud, we don't really have to be making those compromises anymore. We can actually build out the system. So this is what I wanted to talk about today with that data lifecycle optimization. It's the idea of being able to build out the foundation so that you can do what you need to do with your data. What we talked about today was architecture and availability, and hopefully we've got a few questions, and hopefully there's about 10 minutes left, which I think there is. So do we have any questions today?
Yes, we do. We have just a couple, actually, not a lot of them. The question is,
Okay.
What questions can I ask to get management to quantify the importance of their data? RTO and RPO are impossible to determine when the business has not prioritized or recognized data and availability as an asset. Can you hear me, Jason? Jason, can you hear me?
Can you hear me now?
Oh, now I can.
Okay. I just bumped my microphone and then it got weird.
Oh.
I did hear the question though.
Okay.
So the questions you're going to want to ask is, if you want to start a conversation around what's the value of the data? You know, what is it that they're doing with the data, and what expenses do you have if the data is down. Now, when you're looking at it, it's going to be a matter of what is the report that's being generated, and what do you do with that report once it's been generated. It really ties into the idea of building actionable business intelligence platforms or business analytics platforms. If we're building out business analytics platforms and there's no real value associated with them, then it's exceptionally hard to find out what the value is. But if you get that value and you can understand that value and have that call to action, you can tie that into what it is that's going on and being able to establish that value. And that's why that call to action when it comes to reporting platforms is so important. And hopefully that helps answer the question.
Yeah, I think so. Okay, and actually the only other question we have is, will you be sharing your slides with us?
Oh, absolutely. I'll share the slides. I'm going to send them as a PDF.
Perfect.
As soon as this is done, and then I'll also put them up to SlideShare.
Okay, awesome. And that's it. And thank you so much, everyone, for joining us. And thank you, Jason, for an awesome webinar.
Thank you.
Okay, bye.